Have you ever wondered how a planet is born? The birth of a planet is an intricate ballet of cosmic forces, a performance billions of years in the making. Imagine a vast cloud of dust and gas floating in the vast expanse of space. This is not just any dust, but the remnants of long-dead stars, rich with elements like iron, silicon, and oxygen. The gas, primarily hydrogen and helium, is the fundamental building block of the universe. As time goes on, the force of gravity begins to pull this dust and gas together. Tiny particles start to clump, forming larger and larger aggregates. Think of it like a snowball rolling down a hill, growing bigger and bigger as it sweeps up more snow. This is how a planet starts to form. But not all planets are created equal. There are terrestrial planets, like our Earth, made primarily of rock and metal. These planets form closer to their parent star, where it is hot enough to melt the dust and gas into a molten mass. As the planet cools, it solidifies into a solid rocky body with a dense metal core. Then there are the gas giants, such as Jupiter and Saturn. These behemoths form further out, where it is cooler. The dust and gas do not melt, but instead form a dense core surrounded by a thick atmosphere of hydrogen and helium. The immense gravity of these planets can even capture other elements, like methane, ammonia, and water, adding to the complexity of their atmospheres. So the birth of a planet is not a simple process. It's a complex interplay of forces and elements, a cosmic dance choreographed by the laws of physics. From a simple cloud of dust and gas, gravity crafts a world, complete with mountains, oceans, and maybe even life. So the birth of a planet, as you can see, is a cosmic dance of dust and gas. Once formed, how does a planet find its path and start to spin? This is where the magic unfolds, in the dance of celestial bodies across the vast cosmic stage. This dance is not random or arbitrary, but follows a script written by the laws of physics, specifically a principle known as angular momentum. Think of a figure skater twirling in place. As she pulls her arms in, her spin speeds up. This is because her angular momentum must be conserved, and if her arms come closer to her axis of rotation, her speed must increase to compensate. In a similar fashion, a planet forms from a swirling disk of gas and dust. As this material coalesces to form a planet, it brings with it the angular momentum from its original circular motion. This momentum is preserved and manifests as the spin of the newly formed planet. But what about the path a planet takes, its orbit around its star? This, too, is a result of the conservation of angular momentum. As the planet forms, it is not only spinning but also moving in a path around the star. This motion is a delicate balance between the gravitational pull of the star and the inertia of the planet, a product of its mass and velocity. The result is an elliptical orbit, a path that is not quite a perfect circle but rather an elongated loop. This is due to the gravitational pull of the star being strongest when the planet is closest, pulling it faster and causing the orbit to curve more sharply. So, from the spin of a planet to its orbit around a star, these movements are not just a cosmic ballet, but a symphony of physics, a dance choreographed by the principles of angular momentum and gravity. This dance may seem complex, yet it is simply the universe following its own fundamental rules. A planet's spin and orbit are a result of the laws of physics at play. These laws create the rhythm and harmony of the cosmic dance, a dance that spins each planet into existence and sets it on its unique path through the stars. But what happens when a planet stops spinning? Well, it's not as simple as flipping a switch, but there are a few reasons that could cause a planet's spin to slow or even stop altogether. One of these reasons is a phenomenon known as tidal locking. This happens when the gravitational pull from another celestial body, like a moon or a star, causes one side of the planet to constantly face that body. Over time, this gravitational tug can slow down a planet's rotation to the point where one day is as long as 1 year. Another potential cause is the loss of angular momentum. You see, planets spin because they have this thing called angular momentum, which is conserved unless acted upon by an outside force. If a planet were to lose this momentum, perhaps through a massive collision or through the gravitational interactions with other celestial bodies, its spin could slow down significantly. Now let's imagine a world where a planet has completely stopped spinning. What would happen then? Well, one of the most immediate consequences would be extreme temperature differences. Without the rotation to evenly distribute the sun's heat, one side of the planet would be in constant daylight and become scorchingly hot, while the other side would be in perpetual darkness and become freezing cold. This could lead to the formation of massive storms at the boundary between the hot and cold sides, creating a rather inhospitable environment. Moreover, the cessation of spin could potentially weaken or even eliminate the planet's magnetic field, exposing it to harmful solar and cosmic radiation. This would make life as we know it almost impossible to exist. In conclusion, the spin of a planet is more than just a cosmic ballet. It plays a crucial role in maintaining the environmental conditions necessary for life. The cessation of a planet's spin can lead to some drastic changes in its environment. So next time you feel the world is spinning out of control, remember, it's a good thing that it's spinning at all. What conditions are necessary for life to form on a planet? Let's delve into the genesis of life. This journey takes us to the crux of existence, the perfect blend of conditions which enable life to flourish. At its most basic level, life as we know it requires a certain set of conditions, including a suitable temperature, the presence of water, and the right combination of atoms and molecules. Imagine a planet, not too close to its star to be scorched and not too far to be frozen. This is what scientists call the Goldilocks zone, where the temperature is just right for liquid water to exist. Water, as we know it, is the elixir of life. It's the universal solvent, the medium where all biochemical reactions occur. Next, let's talk about the building blocks of life, atoms and molecules. Life as we understand it is primarily carbon-based. Why carbon, you ask? It's because carbon atoms have the unique ability to form stable, complex, and varied structures. They bond with other atoms, including hydrogen, oxygen, phosphorus, and nitrogen, creating a rich variety of molecules that form the basis of life. Now, the right combination of these atoms and molecules under the right conditions can lead to the formation of genes. Genes, the blueprint of life, are composed of deoxyribonucleic acid, or DNA. DNA is a complex molecule that carries the genetic instructions used in the growth, development, functioning, and reproduction of all known living organisms and many viruses. These conditions, however, are just the starting point. The genesis of life is a process that takes billions of years, involving numerous complex biochemical reactions. It's a cosmic dance, choreographed by the laws of physics and chemistry, where every step must be perfectly timed and executed. Indeed, the genesis of life is a testament to the incredible resilience and adaptability of nature. It's a story of how, against all odds, life finds a way. Life as we know it hinges on a delicate balance of conditions. How does a planet generate a magnetic field, and why is it important? This question takes us to the heart of a planet, its core. The core of a planet, particularly one that's rich in iron, plays a crucial role in generating a magnetic field. Picture the core as an immense dynamo. As the planet rotates, so does this iron-rich core. This rotation generates electrical currents, which in turn create magnetic fields. It's a cosmic dance of matter and energy, resulting in a magnetic shield that envelops the entire planet. Why is this important, you may ask? Well, this magnetic field acts as an invisible force field, protecting the planet from harmful solar radiation. Without it, life as we know it would be impossible. Solar winds, which are streams of charged particles from the sun, would strip away the atmosphere, leaving the planet barren and lifeless. It's like having a personal bodyguard, warding off the harmful cosmic rays that threaten to wreak havoc. But the story doesn't end here. The sun, the fiery ball of gas that sustains life on our planet, also plays a part in influencing a planet's magnetic field. The sun's own magnetic field, carried by solar winds, interacts with a planet's magnetic field. This interaction can cause fascinating phenomena, like the auroras we see at the poles of our Earth. Moreover, these interactions can also influence the strength of a planet's magnetic field. When the sun's activity is high, it can in fact cause a planet's magnetic field to fluctuate. However, the core of the planet continues its relentless rotation, ensuring that the magnetic field, though it may waver, never disappears altogether. In conclusion, the magnetic field of a planet is not just a product of its core's rotation. It's a dynamic entity, influenced by the very star it orbits, and an essential shield that safeguards life. The magnetic field of a planet is its invisible shield, protecting it from the harshness of space. Could we possibly breathe life into a dead planet? Now that's a question that has captivated scientists and sci-fi enthusiasts alike for decades. When we talk about reviving a dead planet, one celestial body immediately comes to mind: Mars, our red neighbor. Terraforming, the process of transforming a hostile environment into one suitable for human life, isn't as easy as flipping a switch. It's a complex process that involves a series of steps, each posing its own unique set of challenges. Firstly, we need to create an atmosphere. Mars, for example, has a thin atmosphere that is 95% carbon dioxide, which is not conducive to human life. We'd need to find a way to increase the atmospheric pressure and introduce oxygen. This could potentially be achieved by releasing the planet's trapped carbon dioxide or by introducing oxygen-producing organisms. Next, we need to address the temperature. Mars is frigid, with average temperatures around -80 degrees Fahrenheit. To warm it up, we could use greenhouse gases or vast mirrors to reflect sunlight onto the surface. Then we must consider water. Mars does have ice, but we'd need to melt it and create a stable water cycle. This could be done by heating the planet or by importing comets rich in water ice. Finally, there's the issue of Mars' weak magnetic field. Without a strong magnetic field, solar radiation could strip away the atmosphere we've worked so hard to create. One possible solution is to build a planet-wide magnetic shield. But let's be clear, these are all just theories at this stage. The technology required is beyond our current capabilities, and the ethical considerations are enormous. We're talking about fundamentally altering an entire planet, after all. While reviving a dead planet remains firmly in the realm of science fiction, it's an exciting thought that stirs the imagination. So as we continue to explore our universe and understand more about our own planet, we keep the dream alive. Who knows what the future may hold? From birth to death, a planet's journey is a fascinating tale of cosmic forces. This journey, we've discovered, is dictated by a series of intricate processes and phenomena, each as captivating as the next. We began our exploration with the formation of a planet, a process that sets the stage for all that follows. This birth is a cosmic ballet of particles and forces, culminating in the creation of a celestial body that's as unique as it is complex. The spin of a planet, the next chapter in our story, is not merely a physical phenomenon, but a defining characteristic. It is this rotation that gives rise to days and nights, shapes climates, and even influences the evolution of life. But as with all things, this spin comes to an end. The cessation of a planet's rotation marks the beginning of its end, a process that, while slow and gradual, is as inevitable as time itself. The causes for this slowdown are many and varied, from internal dynamics to external influences. Yet, even in this seemingly barren state, a planet holds the potential for life. The combination of particles and atoms in the right environment and at the right temperature can give birth to genes, the building blocks of life. This genesis, we've learned, is not a matter of chance, but a testament to the power of the universe. The generation and modulation of a planet's magnetic field is another critical aspect of its existence. These magnetic fields, often powered by the sun, protect the planet from harmful cosmic rays and contribute to its overall stability. In our quest to understand these cosmic phenomena, we've also delved into the possibility of reviving a dead planet. Through data analysis and scientific study, we've begun to fathom the potential of giving birth to a planet like Mars. The mysteries of planets and their magnetic fields continue to captivate us, inviting us to explore, learn, and dream. As we unravel these mysteries, we not only deepen our understanding of the universe, but also ignite the spark of curiosity that drives us to keep exploring. Welcome back, fellow cosmic explorers. We are MindArt 100, your guide to the mysteries of the universe. Our journey today has taken us through the birth, life, and death of a planet, and we hope it has left you as awestruck as it has us. The universe is a vast, intricate tapestry, and we've only just begun to unravel its threads. If our journey today has sparked a curiosity within you, a longing to delve deeper into the mysteries of the cosmos, then we invite you to join us on this extraordinary expedition. Subscribe to our channel and allow notifications to ensure you never miss an update from us. Each video we create is a step further into the unknown, a step closer to understanding the secrets of the universe. As we close this chapter of our cosmic journey, we leave you with this thought. The universe is not just out there, it's within us, around us, a part of us. We are all stardust, born from the heart of a dying star, spinning on a tiny blue dot in the vast cosmic ocean. So join us on this cosmic journey. Subscribe and stay tuned because the universe is waiting to be discovered. Until then, keep looking up, keep wondering, and remember, we are all made of star stuff. This is MindArt100, signing off, but not saying goodbye. Until the next time, stay curious.